Okay, so I want to look at converting to and from binary. Computers run on binary zeros and ones, so that's the base 2 number system. In a computer, it's sort of on or off. So it's good to know a little bit about what the binary number system or base 2 number system consists of. Also, I'm a math teacher, so I think it's kind of cool converting between. So typically, we use a base 10 number system, or the decimal number system. It has digits 0 through 9, and each place value represents a power of 10. And in each of those place values, you can have 0 through 9 of each of those values. So 10 to the 0 is 1, 10 to the first is 10, 10 squared is 100, 10 cubed is 1,000, 10 to the fourth is 10,000, etc. You go the other way, you get the negative powers of 10. We won't deal with that, the decimal points, the negative powers of 10. We'll just look at positive whole numbers. So 3,246, it really means we have 3,000s plus 200s plus 4 tens plus 6 ones. It's a 3 in the 1,000 position, a 2 in a hundreds position, a 4, so it's a 3 here in the thousands, a 2 in the hundreds, a 4 in the tens, and a 6 in the ones. And then you add them all together and you get 3,246 that we typically think of. Okay, the same thing in base 2, the binary number system, except the only digits that we have are 0 and 1. So we're not going to get, like above, we can have 3,000s. Well, for each place value, we can only either have it or not have it. So we don't need to have the S on these things. So 2 to the 0 is 1, 2 to the first is 2, 2 squared is 4, 8, 16, multiply by 2, you'd get 32. Multiply again, you get 64, and these would be our place values as we go out to the left for larger and larger numbers. And then you either have that value or you don't have it. So if we look at 1, 0, 0, 0, 1, 1, so we have, starting on the left is the easiest place, 1, 1, followed by 3 zeros, 0, 0, 0, and a 1. So that number, 1, 0, 0, 0, 1, 1 represents 132, which is 2 to the 5th, plus 1, 8. Oh, I forgot the 8. I'm going to change this. Hang on. Forgot I changed this problem. I wanted 1, 0, 1, 0, 1, 1. So I added a 1 here, changed it. So it should be 1, 0. This should not be a 0. It should be a 1. I'm just going to change that. 2A1, 1. Oh, let go. Using my pen. Okay, try this again. So it should be 1, 0, 1, 0, 1, 1. And that would be 132, 2 to the 5th, plus 1, 8, 2 cubed, plus 1, 2, 2 to the first, plus 1, 1, 2 to the 0, or 32 plus 8 is 40, plus 3, 43. Okay, so how do we convert back and forth? So first we'll look at converting from decimal to binary. What we want to do is figure out our place values for the powers of 2, and I'm going to come over here and just start on the left and go 1s, 2s, 4s, 8s. I'm just multiplying by 2 each time. 16, 32, multiply by 2 again, you get 64. So 64 is the largest power of 2 that's smaller than 70. Those are all the powers of 2 from left to right, starting at 2 to the 0. So we take our 70, and we need 164. And when I take away 64 from here, we're left with 6. So there can't be any 32s or 16s or 8s, but there could be a 4. In fact, we have 1 4 in there. So then I'll take away 4 from there. That leaves me with 2, so there's 1 2 left. Take away 2, it's going to leave us with 0 left. So 0 there. So 1 0 0 0 1 1 0 represents 70 in decimal. And again, that's 162 plus a, or sorry, 164 plus a 4, that's 68, plus 2, that's 79, 60, 168, 69, 70. Okay, so what if the number is larger, like 413? You know, you just need to go higher powers of 2, but you know, powers of 2 are not hard to figure out because you just keep multiplying by 2. So we start at 1. I'm just going to put some blanks in here, make it easier for myself. I don't know how many I'll need, but we start at 1, then multiply by 2, you get 2, multiply by 2, you get 4, times 2 is 8, and then 16, times 2 is 32, 64, 128, 256, and I know I can see if I multiply that by 2, it's going to be bigger than 413. So we have 256, and I have to subtract that from here. Let's see if I have my, get my math on here. 0, 13 minus 6 is 7. Cancel the 4, get a 3. 10 minus 5 is 5. 3 minus 2 is 1. So we got 157 left. So certainly I can put a 128 in there. So I take away 128 from here. I borrow 4. 17 minus 8 is 9. 4 minus 2 is 2. So the next number, what's left is 29. So we can't have any 64s or 32s. They're too big. 29 would contain a 16. So I can subtract the 16 off of here. And that's going to leave me with 13. And 13 contains an 8, certainly. So take that 8. 13 minus 8 is 5. Oh, that pen went crazy again. Sorry. Come on. 13 minus 8 will give us 5. There's buttons on this pen, and every time I hit it, it does this weird thing. It just keeps chasing my pen around. So there's certainly a 4 left in there, and I'll just come over here because I'm out of room. So 5 minus 4 is 1. That can't contain a 2, so there's a 0 there. And we have 1, 1. We should always end up with 0 as we do the subtracting out of powers of 2 here. So the binary number 1100111101 represents 413 in decimal. Okay, how do we go the other way? So converting from binary to decimal, you know, that might be a little easier. I don't know. I think they're both about the same. You just have to set up the same number of place values. So 101 has 3 place values, and I'll just come over here as long as I remember what they are. It'll be pretty straightforward. 1 0 1, well, this is the ones, and 1 times 2 is 2, and 2 times 2 is 4. So this number is 1 4 plus 1 1, or 5 in decimal. Down below here, I need 1 2 3, I need 6 spaces. So I'll just set up my 6 spaces. 3 4 5 6. I prefer to just redraw this rather than trying to put the numbers under here, because you know, especially when you get up to 2-digit numbers, they don't fit under 1 digit. So we'll do this quite a bit as we go through the quarter for other purposes as well. When we're trying to indicate characters in a string or something, it's hard to write stuff underneath something that's typed. So you just create the space by making these spaces, and now it's 1 1 0 0 1 1. So 1 1 0 0 1 1, and now that's 32 plus 16 plus 2 plus 1. 9, 10, 11, 51. Let me make sure that's right. That's 48, 49, 50, 51. Great. And one more. So I might have a few of these on the test. Let's see how many digits we have. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, 10 digits. Oh my gosh, that'd be a big one. 1, 2, 3, 4, 5, 6, 7. Probably not 8, 1. Probably not one this big because I'm not really testing. Do you know your powers of 2? They're not hard to know because we don't need to know them. We just multiply by 2 each time. But at some point we can't do them by hand. We have to pull out a calculator and figure out what they are. That's 2, 5, 6, and that's gonna be 512. 512. Let's see if that's right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we've got 1, 0, 0. So 1. So we did the hard part. Now we're just filling in the numbers. 1, 0, 0, 1, 0, 0. Easy to make a mistake here because you could count wrong or something. 1, 0, 0, 1. So that number is 512 plus 64 plus 8 plus 1. And I might sort of do this cheat. That's 520 plus 64 would be 584, 585. Make sure that's right. 10, 15, carry 1, 8, yep, 585. I guess that wasn't too bad. Okay, so that's converting back and forth to decimal. The trick is, set up your binary sort of place values. Remember, you start at 1, which is 2 to the 0, and then 2 to the first, 2 squared, 2 cubed, 2 to the fourth, etc. Or just start with 1 and multiply each value by 2 each time to get to the next one. All right, that's it. And like I said, there'll probably be 1 or 2 of each on our first exam, sort of convert to decimal, from binary to decimal, convert from decimal back to binary. And I think there's a few on the practice sets as well.